With Omilia Cloud Platform, a fluid conversational experience is achieved by orchestrating a series of bots and assimilating their knowledge into a single, unified intelligence. Many apps are bots with intelligence and expertise on a specific kind of information. For example, some mini apps specialize in date information, like date of birth. Others specialize in numeric information, like credit card numbers. Others specialize in getting external information, like web services. Intent mini apps specialize in effectively classifying a user inquiry. Intent mini apps offer pre-packaged models that come built with hundreds of intents and a set of pre-trained utterances. The classification process expressed by intent mini apps can also provide a series of common answers, like FAQs, to customers. These are called announcements. Any announcement is an opportunity to give customers quick answers or to direct callers to self-services hosted within OCP. Once an announcement is defined, mapping it to an intent is simple. Just select it from the list of known intents. You can further parameterize the announcement by only enabling it to play for certain entity values defined by the NLU. In this way, you can have very fine-tuned control over information that is provided to customers. Once you've configured the announcement, you can tell the intent mini app what to do next. Perhaps the mini app should return call control to the orchestrator. Just select exit, and the orchestrator will take over. You might tell the intent mini app to re-ask the caller, "Is there anything else I can help you with?" You can also automate this process, allowing it to consume external content providers and knowledge base sources if desired. If you want to create a fluid, natural conversation between mini apps, just use OCP's orchestrator. Orchestrator retains all knowledge of the conversation and constantly reevaluates the conversation based upon what it knows. Orchestrator activates the correct bot at the right time and feeds the bot the assumptions it needs to make to enable it to successfully obtain information. Let's design a flow for card payment and balance inquiry self-services. Because Orchestrator and all the mini apps it assimilates are intelligent, the call flow design is as simple as drawing out successful outcomes. Errors and failures are handled intelligently. First, we need to identify the intent. That's the expertise of the intent mini app. Then we need to go down different paths based on the card balance and card make payment intents. If we're going to tell a customer something about their account, we need to authenticate them. In this case, a card number and a phone banking PIN. For now, let's hand off all other kinds of intents to an agent by grabbing the packaged agent transfer step from the palette. Customers can be transferred to ACD skills, PSTN phone numbers, SIP termination points, or more. To authenticate the caller, let's grab the web service for authentication and place it on the palette. The web service already has the parameterized queries to authenticate the caller and retrieve their balance. Just pass in the values that Orchestrator receives from the credit card and PIN mini apps. You'll get a balance from the web service that you'll use later in the announcement mini app. Map it to a variable here. You'll get a payment due date from the web service. Map that to a variable. The web service returns the account number, which we'll also need. Save it, and we're back to Orchestrator. After authenticating the caller, if they wanted to hear their balance, we're going to need an announcement mini app. Let's put a new condition on the palette. Grab the announcement mini app from the list of mini apps. Define the card balance intent, and save it. We just built the card balance self-service in a few clicks. Next up is making a payment. Let's start by asking the caller what bank account number they want to pay from. Grab the account number mini app that has been optimized around known account number formats. Now let's point card payment intents in this direction and save your changes. We'll want to confirm the amount of the payment, so grab the amount mini app. And also grab the date mini app so we can confirm the date of the payment. We'll want to grab the web service mini app so that we send the necessary info to the web service and pass in everything we've gotten from the mini apps we just used. Let's also capture the return values from the web service so that we can tell the caller if the payment was successful. It's also important to note that these mini apps can be grouped into a structured flow for reusability and reporting purposes. We want to check in with the caller at this point and ask them if there's anything else we can help them with. In that case, let's put re-ask intent at the end of each path. In this way, callers are returned to the top of the flow in a seamless conversational logic. Although we are creating a happy path logic here that looks like a rigid state machine or directed dialogue, the reality is far from it. Orchestrator can direct control to any other part of this flow as needed. This is a network of intelligent bots, and Orchestrator enables them to share their expertise in a fluid and conversational fashion. The power of OCP's bot orchestration approach is the ability to follow a simple design without sacrificing anything in terms of conversational logic. This makes conversational AI efficient and easy to deploy. Done. You just built a banking bot that is easily able to understand hundreds of intents and already knows how to handle payments and balance inquiries. Let's try this out. Watch as the bot easily understands the customer who states their inquiry in a conversational way. Each minApp picks up in turn and is ready to deal with customers who don't give easy answers. Note the mix of written language and numbers. Each minApp knows what it is looking for and how to focus on the parts that are relevant to the question at hand. The dialogue is following the logic as written by Orchestrator. The ability to run the simulator at any time during application development is a huge aid to conversational AI clients. The dialogue has returned the balance and gone back to the top of the flow in a fully conversational fashion. No context is lost, however. The customer can still ask to repeat the information and will get this easily out of the box. You can also ask for the payment right away. Even though we are back to the top of the flow, the AI won't repeat past questions and will even infer new information, like the amount and the payment date. It just needs to know the account number the customer is paying from and to confirm the payment details. Let's change our mind. Try to throw the bot for a loop. Looks like that didn't work. The bot has kept up with the changed amount and is ready to make that payment. Payment is posted, and we are back to the top of the application, ready to take the next request. We still have all the context we need at this point. Let's try to pay another card. Bot is still keeping up. It starts by asking which number, but let's try to mix it up again. Let's try to challenge the AI a bit with a confusing phrase. The AI asks a general disambiguation in an attempt to confirm the correct intent. Let's ask something we didn't have a defined self-service for. This causes a transfer to the contact center, who will have a chance to further assist the customer. Let's look at some of the minApp features that enabled the experience you just saw. As we've discussed in other demos, minApps have all the pre-trained ASR and NLU models needed to understand customers. Most of the magic of minApps is therefore in their fluid conversational design. Validation rules are offered pre-built by Omilia with full customization available. Every minApp will confirm the capture if confidence is below a defined threshold. minApps understand if users request additional time to answer a question. minApps recognize when users request to speak to a live agent. minApps provide error handling for unexpected things that occur on a conversation. Errors are defined based upon conversational AI best practices. Prompts are pre-populated based upon design best practices, and error thresholds are defined by default based upon real-world experiences. They can be reconfigured if desired. Each minApp supports data models for non-voice channels, which include the ability to define buttons and other quick inputs. And each minApp has text-to-speech settings included. As shown here, any minApp can accept a variable text. These variables are sent to the minApp by Orchestrator and cause a text-to-speech file to be generated on demand. Additional business logic can be developed using standard JavaScript libraries if needed. Web service minApps are configured to reach REST API endpoints and support production, dev, and UAT URLs. Variables can be used in headers and body elements. Web service outputs can be processed prior to returning to Orchestrator. This enables clean and consistent outputs and an easy unit testing approach. As with announcement minApps, support for additional JavaScript functions is also available if additional logic is required. Web services can play comfort messaging to customers so that they know that we are still listening when a customer-provided REST API is running slow. IntelliMiniApps offer detailed internal analysis of data and results, which aid in additional inferences that are relevant to the application design.